Hello there, welcome to the AS Maths Pure June 2023 paper. Here we're looking at question 12. Show that the equation 4 tan x equals 5 cos x can be written like this. So the way we're going to do this question is we're going to write out the top line of algebra, top line of trigonometry, and then through a series of trigonometric steps, we're going to turn it into this expression below. So first thing I'm going to do is remind myself that tan x can be rewritten as sine x over cos x. So that's going to give me 4 can join the sign on the top, equals 5 cos x. Let's multiply the cos onto the other side, so 4 sine x is 5 cos squared x. Okay, in the next line from this line to this line, we're now going to remind ourselves that cos squared can be rewritten as 1 minus sine squared, and that comes from the sine squared plus cos squared equals 1 identity. So we're going to get 4 sine x equals 5 brackets 1 minus sine squared, and then we're going to expand the brackets. Make sure you did put brackets around that, because it's going to become 5 minus 5 sine squared. I bet a good number of people have missed out the 5 on the sine squared at that point. And the final thing we're going to do is add the 5 sine squared onto the left and subtract the 5 onto the left as well. There we are, as required. Okay, so there we are. That's the answer to question A. Let's now move on to question B. Hence, solve between 0 to x to 360, 4 tan x equals 5 cos x. Well, what I'll do there is I'll use my answer from part A, which is that this equation is equivalent to 4 to 5 sine x plus 4 sine x minus 5 equals 0. What I'll do is I'll substitute that straight into the quadratic solver in my calculator. I don't think it factorizes. And this tells me that sine x is equal to minus 2 plus or minus root 29 over 5. So that's what the quadratic solver in the calculator tells me, that sine x is equal to this. So now we're going to get 2 sets of answers. When we use the positive value of that, we're going to get x equals 42.6 to 1 decimal place. And then for the sine graph, that's the sine graph. If that's 42.6 and this point here is 180, we need to do 180 minus that original answer to get us to our second solution of 137.4. And on the second solution, where it's minus 2 minus root 29 over 5, we get no solutions here because the value of minus 2 minus root 29 over 5 is less than minus 1, and you don't get any solutions for sine when you're less than minus 1. So there we are. Those are our 2 solutions to this question to 1 decimal place between 0 to 360. Okay, let's now move on to part C. Hence, find the number of solutions to the equation 4 tan 3x equals 5 cos 3x in the interval between 0 to 1800. Briefly explain your answer. Okay, so when we go from 0 to 360 to 0, I'm going to ignore the 3x on here for the moment, to 0 to x to 1800. This is going to multiply the width of our solutions by 5. So the number of solutions is going to multiply by 5. Also, as we move from 4 tan x to 5 equals 5 cos x to 4 tan 3x to 5 cos 3x, the graph of this whole question, or if we were to graph this function here, would squish in by a factor of 3. If we think about our graph transformations, we know that a graph transformation of f(a)x squishes the graph inwards by a scale factor a, or you actually think of it more as a scale factor of 1 over a. So all of the graph gets squished inwards by 3, by a multiple of 3. So therefore we're going to get 3 times as many solutions between 0 to 1800. So this is going to multiply our number of solutions by 3, because, and we need to write a bit of a reason here, because the graph enlarges by scale factor 1 over 3. So we get 3 times as many solutions, and this is because the range is 5 times as big. So how many solutions do we get? Well, originally we had 2 solutions, then we've expanded the range by 5 times, so we're going to get 5 times that many, and then when we put a 3 in there, we've squished our graph inwards by a factor of 3, or by a factor of a third, so that we get 3 times as many solutions. So in total for this question here, if this was our question, we would get 30 solutions. So there we are, that's the answer to question 12 with a total of 9 marks. Let's now move on to question 13.